Now, continuing with our measures of position, we will see percentiles, deciles, and quartiles. The second measure of position that we can use are the percentiles. Percentiles divide a dataset into 100 equal parts, in which the pth percentile is a value that at most p% of the observations in the dataset are less than this value, and the remainder of the values are greater. For example, if an NHL hockey player point score is of 22, and that is the 32nd percentile of all point scores in the league, this means that 32% of the point scores in the league are lower than 22, and 68% of point scores in the league are more than 22. But be careful, because percentiles are not the same as percentages. Indeed, if you scored 75% on your QM midterm, this does not mean that 75% of the students did not do as well as you, because you could have scored the highest grade, the lowest grade, or be straight in the middle. But if your score of 75% corresponds to the 82nd percentile, then you did better than 82% of the students and not as well as 18% of the students. There are many methods to calculating percentiles, and all of these methods work better the larger the data sets. But here is the formula we will be using, where the percentile is equal to the numbers of values below x plus 0.5 divided by n, all of this which you multiply by 100%. Let's do an example. Imagine that you want to find the percentile or rank of the student that travels 3 kilometers every day to come to university. Here is the data that you found by sampling people in your class. The first thing to do is to place values in increasing order. Now we can substitute in the formula. So we have 9 values that are lower than the 3 kilometers, to which we will add 0.5. So it gives us 9.5. We divide by 15, which is the number of values in our data set, multiply by 100, gives us 63.33. Unless this is a perfect round value, you must always round up. So we can say that the student that travels 3 kilometers per day travels longer than 64% of his or her colleagues. But what if we want to find the value that corresponds to a certain percentile? With our same example, let's say we wish to find the 62nd percentile. First, we must arrange the data in order. Then, we use this equation, where C is the rank of the value, N is the total number of values as usual, and P is the percentile. As such, C is equal to 15 times 62 divided by 100, giving us 9.3. If C is not a whole number, round it up to the next whole number. So in this case, C is equal to 10. Now, step 3, we must find the value that holds the 10th rank. So you simply count from 1 to 10. And it says here that the 62nd percentile is 3 kilometers. So we can state that up to 62% of students travel less than 3 kilometers every day to get to university. Now, if we were looking for the 40th percentile, C would have been equal to 6. When your C is a whole number, you must use the halfway value between C and C plus 1. So in this case, we would use the halfway value between the 6th and the 7th rank, and then divide them by 2. So in this case, 1.75 would have been your 40th percentile. Other measures of position are quartiles and deciles. Quartiles divide a distribution into 4 groups separated by Q1, Q2, and Q3. Q1 is the same thing as the 25th percentile, Q3 is the 75th percentile, whereas Q2 is the 50th percentile and actually the median of your distribution. You can calculate these using the exact same formula than for the percentiles. Quartiles can be used for a rough estimation of variability by calculating the interquartile range. This is the difference between the third quartile and the first quartile. If we were to calculate the IQR of our daily student travels, we would first have to find the third quartile like this. Remember that the third quartile is actually percentile 75th. So 15 times 75 divided by 100 gives us 11.25. Round up to give us the 12th rank. So our 12th value is 6. Our third quartile would be 6. And then we do the same thing to find percentile 25, which is quartile 1. And we are looking for the value at the 4th rank, which is 1. Then to find the interquartile range, we do quartile 3 minus quartile 1, which is 6 minus 1. Our IQR is of 5. We can also use deciles, which separate your data sets in 10 equal parts like this. Note that D1 is equal to the 10th percentile, D9 is equal to the 90th percentile, and D5 is equal to your 50th percentile, and that is also the median. Measures of position, mainly the quartiles in the interquartile range, can help us identify extremely high or extremely low values in our data sets. Remember that extreme values really influence your distribution mean, so it's a good idea to check if you have extreme values, also known as outliers, before using the mean as a central tendency measure. Here's how you check your data set for outliers. Step 1 is to arrange your data in order. Step 2 is to find the IQR. Step 3 is to multiply the IQR by 1.5. Step 4 is to subtract your value from step 3 from Q1 and add the value to Q3. Step 5, check your data. Any value that is lower than the Q1 minus 1.5 IQR or larger than Q3 plus 1.5 IQR is an outlier. Let's check if we have any outliers in our student daily distance data set. We have already calculated the IQR as being of 5, so we will not redo steps 1 and 2. So step 3 states that we must multiply the IQR by 1.5. 5 times 1.5 is 7.5. Step 4, add the obtained value, 7.5, to Q3 and subtract that 7.5 to Q1. So Q1 minus 7.5 gives us minus 6.5. Q3 plus 7.5 gives us 13.5. Step 5, let's check the data to see if we have any outliers. We do not have any values that are lower than minus 6.5, but we do have one value that is higher than 13.5, which is 100 kilometers. So our data does have one outlier, and using the mean as a central tendency here can be very misleading.